Hi and welcome to my channel. So is a single firewall enough for your network? What if traffic spikes or connections max out? That's when load sharing in Check Point's ClusterXL becomes essential. So multiple gateways work together, splitting traffic, boosting performance, and keeping your network always available. So let's see how it works. So here you can see my topology. I got these two gateways. This is my management server. And this way they go out to the internet. And we have a client here to test. So why load sharing may be required? So you need more throughput than a single gateway can provide. If one firewall's CPU cores, connection capacity, VPN throughput are not enough, load sharing allows two or more gateways to handle traffic in parallel. So multiple gateways process traffic, aggregate throughput increases, and horizontal scaling. This is the most common reason to use load sharing. So load sharing, we have two types. We have multicast and unicast. So let's start with multicast. So here in Smart Console, if we double click our cluster object here on the ClusterXL and VRRP, you can choose load sharing like this. But to be able to use the load sharing, you need, so I had to follow this SK. So ClusterXL load sharing mode in 80/20 and higher. So you need to follow this SK. So create this environment variable. And then in the management server, we needed to change some text files. And then you need to restart your computer and restart CP stop and CP start to be able to choose multicast or unicast here. Okay, so with that said, so let's choose multicast here. So ClusterXL load sharing multicast mode is a method used by Check Point to distribute network traffic across multiple cluster members efficiently. So first we have the multicast MAC address. So in the multicast mode, the cluster's virtual IP, the VIP IP addresses are associated with multicast MAC addresses. This ensures that all packets sent to the cluster, acting as a default gateway, reach all cluster members. And this is an example of what the MAC address of multicast. So when you see this 010058, this is a multicast MAC address. So this is how our multicast MAC address will look like. So let's go back there. So packet distribution. So each cluster member receives the packets and independently decides whether to process them. Decision-making process ensures that at least one member processes each packet, preventing traffic from being blocked, and that no two members handle the same packet, avoiding duplication. And then the load is distributed optimally between all active cluster members, making it an efficient way to handle high traffic loads. Each member processes packets based on decision function, ensuring that packets belonging to the same connection are processed by the same member whenever possible. The multicast mechanism is provided by the Ethernet network layer, allowing several interfaces to be associated with a single physical MAC address. This enables selective grouping within networks, unlike broadcast, which binds all interfaces in same subnet to a single MAC address. So here on the configuration page, we can see here use sharing methods based on IPs, ports, SPIs, IP ports and IPs. What are these? So what is the difference between these? So IP ports SPIs. This method configures each cluster member to inspect all connections with the same source and destination IP address, the same source and destination ports, and the same IPsec SPI numbers. It is least sticky, so sharing configuration providing the best distribution of traffic between cluster members. This method, this one, the IPs, ports, SPIs, decreases the probability that a certain connection passes through the same cluster member in both inbound and outbound directions. It is the recommended method for optimal load distribution. The second one, this one, IP ports. This method configures each cluster member to inspect all connections with the same source and destination IP address and the same source and destination ports, regardless of IPsec SPI numbers. So use this method if there are issues with distributing IPsec packets between cluster members. And lastly, the last one, IPs. This method configures each cluster member to inspect all connections with the same source and destination IP address, regardless of source and destination ports and IPsec SPI numbers. It is the most sticky sharing configuration, providing the worst distribution of traffic between cluster members. So this method increases the probability that a certain connection passes through the same cluster member in both inbound and outbound directions. So use this method only if there are problems when distributing packets with different port numbers or distributing IPsec packets between cluster members. So now let's apply this. So let's keep everything as is and click OK here. So now we are moving from ClusterXL high availability to multicast, load sharing multicast. So let's install the policy here and see some information about that. So how, for example, how this router will react to that multicast MAC address. So now we are done with the policy installation. So let's go to our client here, open that one and try to surf. Okay, so let's try to ping anything here. So it was working with ClusterXL. And now the problem is, so let's open our router. The problem is ARP and multicast MAC address. So let's open show ARP. As you can see here, now this is my, let's open cluster and look at interfaces here. So this is the external IP, the VIP IP that I have. Okay, so if we back to the router, we can see that we have this MAC address, and that is not a multicast MAC address, because the router maybe Cisco routers does not recognize or they don't want to use these multicast MAC addresses. So to fix this problem, so this IP address changed MAC address, but the router still think that this is the MAC address. This is the MAC address of one of interfaces. This one, this interface, or this interface. But now we are using this MAC address. So what we can do is, let's go to config terminal here, and we can add this command. So we configure a static ARP we say to the router, if you have this IP that has this MAC address, which is the multicast MAC address. Let's say okay, or see what is the problem. Okay, I see the problem here. I think we need to have like this. So now if we exit here and show R again, we can see now we have that MAC address, so the multicast MAC address. And if we're back to our system, to our test environment, let's wait a sec here. Now, as you can see, now we are understanding each other, but because this is a lab, so we will get some tabs here. So now it is working. So it's very important to configure the router. If the router don't talk the multicast MAC address language, we need to configure it on the router like this. So this is 01005E00. This is, when you see this, you know that this is a multicast MAC address. So, so with that said, we can see, let's open our gateways to see how the multicast. So if we try show cluster state here, you can see it is 50-50. So the multicast is always 50-50. And we can try CP view here on the first one. So we can go to advanced and network, for example. Something like that. Let's open the next one. And we will see that both are inspecting traffic. So let's go to network here. You can see here that both are inspecting traffic. It is 50-50. Okay? Because in cluster high availability, one is inspecting and one is zero, exactly zero here. But now we have 50-50 inspection, as you can see. And if let's show cluster state. So now it is 50-50, but if we get one of them down, it will be 100 on one of them. So let's set cluster member admin down, for example. And now you can see that the other one is 100%. So it is always 50-50 or 100%. So let's get that up again. Up. Okay, let's show cluster. And now it is back to 50-50. Okay, so that was the multicast. So now the other type is unicast. So here, okay, let's go to our smart console here and double click that again. Under ClusterXL, you can choose multi or unicast. Unicast, you can see that we have this, they use the virtual MAC, appears again. We don't have it under multicast because we use the multicast MAC address, but under unicast, we are using the virtual MAC. So exactly the same as high availability ClusterXL. So ClusterXL load sharing unicast mode is designed for environments where multicast Ethernet cannot operate, like maybe an old switch which cannot handle the multicast traffic. So here's a detailed explanation of how it works. We have pivot cluster member. So let's install the policy here to see the difference. So unicast, install policy. Let's install once here. So now our policy is installed. So let's head back to our gateways here and try to type show cluster state again. As you can see here, let's exit this one and show cluster state. Okay, as we can see, we have a P here. You can see this P. So in this unicast mode, we have a pivot cluster member, which is this P stands for pivot. So in unicast mode, a single cluster member known as the pivot is associated with the cluster's virtual IP, the VIP. So now this one has the VIP. This member receives all incoming packets sent to the cluster. So the VIP is associated with the physical MAC address of the pivot cluster member. This means that the pivot member's MAC address is used for the VIP. So the VIP cluster member is responsible for distributing the incoming traffic to the other non-pivot cluster members. This is done by applying a decision function to each packet, similar to the process in load sharing multicast mode. So once the pivot member forwards packets to non-pivot members, those members handle the packets without applying the decision function again. This ensures efficient load sharing across the cluster. As we can see here, we can see that the pivot has 30% and the other one has 70%. That is because we have only two gateways. And that is by default. So let's take a look at this admin guide here. So here you can see a total number of cluster members. If it's 2, we have pivot 30%, and we have the other one 70%. And if you have 3 gateways, the pivot is 20, and the other 2 40 and 40, and so on. And if you want to change this default configuration, so to change the default assigned traffic load, you need to edit the GUI database edit. Use this tool to change that. So this is the cluster admin guide. You can read about that if you need, for any reason, to change the default values. So to understand, as we said, as we have seen here, this is 30 and 70, again, according to the default numbers. So last note here, Check Point do not support IPsec VPN when using load sharing with third-party VPN peers. Because if a VPN session begins on one cluster member and Ryotto load sharing, so it is starting on one gateway and so finishing on the other, so we have problem. So Check Point does not support IPsec VPNs on the load sharing clustering. And here again, so let's now try to shut down that one again. So let's take down this one, see what happens. show cluster state, and now we can see that this is the pivot and it is 100%. Now if you go there, it will not work because the router has we have configured the router with a static MAC address. So we need again back to the router and remove that. Let's remove this line. We need to remove this line and everything. So if we do show ARP, so now we can see that this is the multicast MAC address. We need to remove that. Let's do that again. Add no here. And do show ARP. So you can see now we have again the VIP MAC address. And on the gateway, we can use the cp-hub-rom-af to see that this is the virtual MAC address. This one is the same as this one from the router, as you can see. 001C, 7F, oh, it's the same. So I hope this video was useful. So this video is done here. So thank you for watching and see you in the next video.